So it looks like we actually were able to break the bridge. Sorry I was not able to record that on the video, but you know, we try next time. But this problem here, you know, if I'm applying, it's a simple one, right? The bridge had two sides of it, right? The two sides. Here, I'm just looking at one side only this, right? And this, you're going to see, it's very complicated to do all these calculations. I'm just going to go through the steps of it. But on my notes, you will see the calculation for every joint. I'm using the joint method to calculate the forces. And so let's start, and I hope you guys can continue at home the calculation, reviewing my notes. So the first thing is when I have, let's say, 200 newtons there, right? If I put down my force diagram here, I have a force at this joint here that I call joint E, and I'm going to have a force here on A, AY, and AX, right? And then with this alone, I should, because this is in equilibrium, it's not moving, the total sum on the X has to be equal to 0, and the total sum on the Y has to be equal to 0, right? So X, I have only this AX here, so that's 0. But now I have the Y's. So the 200, I put negative because it's going in the direction down, right? Has to be equal to AY and EY. With that written here, so I have one equation, but I have two variables. So I need to find another equation. So I have a system of equations with two variables, so I can solve this. So I'm going to use now this sum of torque. Again, because this is in equilibrium, this sum of torque is going to be equal to 0. So I have here the distance. This is 2 meters. That goes with the EY. Now this one here is right here in the middle. That's, if this is, each member has 1 meter. This is 1 plus 1 is 2. This 1.5 is 1.5. So that's why I have here negative 200 times 1.5. Okay? So from here, I solve now for EY is 150, so I have 150 newtons on this joint. And because this is 200, I have to have 50 on the other one. So 200 and 200 cancel each other, all right? So now I can start with this one because I already know one of the forces on this joint. I can start calculating, you know, each one of this, okay? Now, it looks like here I have going this direction, so I have a tension going in this direction, right? So AB, but this angle here is 60, so I can calculate now that 50 plus AB sine of 60 is going to be equal to 0. Okay? If I get the sum of all forces in this joint on the y direction, that's what I get, 50 plus AB sine 60. So from here I calculate that AB is negative 57.7, right? Has to be higher in magnitude than 50 because this is in an angle. So negative means it's not in tension, so it's in compression, so it's in the other, it's going to be in the other direction, right? Going this way. So once I have AB, I can now calculate CA. How I do that? I just the sum of x's, the force on the x side is gonna be AB cosine plus AC, right? Because those are the two forces that I have. The projection of the AB force on the x-axis plus the AC between these two joints. And when I calculate that, I get a positive value, so that means it is in tension, not compression. So now we have to move on to the next joint, joint B. And how do we do that? Well, we already have AB calculated here. So every time you move to a joint, you have to have something that is known already. So here on joint B, I have AB, and I have, on joint C, I have the CA joint. Okay? Is that exciting? So what I'd like you guys to do is, I'm going to post this tonight, and I'd like you guys to try to go through the whole bridge, every joint, following, the steps that I have on the notes, and see if you understand this, all right? Okay.